Okay, let's solve one of the classic problems. Let's find all of the points x, y that are 3 times as far from this line as they are from that point. So the first step is sketching in the scenario. Here's the point, here's the line. I'm going to try and put a point that I think is maybe, that maybe satisfies this description. So let's see, 3 times as far from the line. So the distance to the line is longer. So, you know, that's not exact, but I just want something that looks approximately right. So, you know, this could be 3 times as long as that. Let's label them. I'm going to call that D1 and that D2. So I want it to be true. Well, before I wrote D1 equals D2 when I wanted the distance from XY to be the same to both the point and the line. Now the distance to the line is 3 times longer. So what that means is that in order for D1 to be the same as D2, I'd have to triple it. Think about that for a second. If D2 is 3 times as long as D1, in order to be equal, I'd have to make D1 be 3 times as long, and now they're the same length. So think about which one is longer, D2, and then think about, oh, you have to multiply the shorter one in order to make it the same length as the longer one. All right, let's derive the curve. So D1, I can use the distance formula. Difference in x's squared, so x minus 0 squared is just x squared, and then y minus 4 squared. Because I'm squaring it, I can write it in the ordering y minus 4, or we could write it in the ordering 4 minus y, either one. And then D2, that distance is 2, and then this distance is y, so that whole height must be y plus 2. If you type that into Desmos, you would see the answer, but let's algebraically restructure it into a nicer form. So I'll square both sides, the 3 squares to become 9, and then this is y plus 2 squared. Let's just rewrite it. I'll try to go one step at a time here. So now let's distribute the 9 in. So now I've got 9x squared, 9 times y minus 4 squared, and then y plus 2 squared. Cool. Okay, so I'm noticing y's on both sides. If I expanded these, I would expect that maybe some type of canceling might occur. So let's put the 9x squared way out here on the left, and let's give us space to expand. So I'm going to write the 9, and then I'm going to have some brackets. And inside the brackets, I'm going to expand the y minus 4 squared. So that should give me y squared minus 8y plus 16. And then over here, I'm going to expand it as y squared plus 4y plus 4. All right, I guess in the spirit of going step by step, let's distribute the 9s. So this is going to give us 9y squared. 9 times 8 is 72, so 72y. And then I'm not going to multiply 9 times 16. That doesn't seem worth it. So let's just keep it as 9 times 16. This is a great bookkeeping technique. There's no reason why we should write this out as a number that's not just the factors. If we manipulate it like this, it's possible later on that it'll simplify, and we wouldn't have needed to multiply the whole thing out. So just keep it that way. All right, let's group things together. Oh, and we still have the 9x squared here. So let's subtract a y squared from both sides. So that's y squared, and this becomes 8y squared. Let's subtract 4y from both sides. So 72 minus 4 becomes 76y. So I'm crossing things off as I deal with them. I'm going to move the constants all over to this side. So here I'll have 4 minus 9 times 16. And then I've still got the 9x squared. All right, so it's worth pausing and asking, what shape is this? I see I've got x squareds and y squareds. So what that tells me is it's not going to be a parabola, because a parabola, you just have 1 power of y, or 1 power of x. It might be a circle, as far as we know. Here would be an example of a circle. If you've got like an x squared term and a y squared term that have been shifted, that would be a circle, with a center not at the origin. But it's hard to tell what we've got when the y terms are separate. So let's try and make this look more like we'd expect a circle to look like. And the way we're going to do that is we're going to combine these two y terms into a single y term by completing the square. Okay, so we've reached the crux of what's going to be difficult in this problem. It's completing the square. We've got a couple of choices here. So one thing I'm thinking is, should we just divide through by a constant to make that coefficient become 1? I'm thinking if I'm going to divide by 8, 9/8 is maybe not the best fraction. And over here dividing by 8 might be okay because I've got some powers of 2 in the numerator. And here dividing by 8 could be okay. Let's try it. Let's try that approach. Let's divide everything by 8 so that it'll be easier to complete the square. So this will be 9/8x squared. This will be y squared. This will be 76 over 8y. And we should probably simplify this in just a second. And then 4 divided by 8 is 1/2. And 16 divided by 8 is 2. So this is 9 times 2. So already this right-hand side is looking simpler. Way to go, us, not multiplying 9 times 16. Okay, let's simplify this 76 over 8. So let's cancel 2's. All right, so in the denominator, 8 divided by 2 is 4. In the numerator, 76 divided by 2, pause for a second, so 70 divided by 2 would be 35. 6 divided by 2 is 3, so 35 and 3 would be 38. So I'll have 38 over 4. Let's divide by 2 again. So this is so 4 divided by 2 is 2. 38 divided by 2, let's see, 40 divided by 2 would be 20. So 38 divided by 2 should be 19. So I'm going to rewrite the whole thing now. It's 19 halves. So I've got 9/8x squared, y squared minus 19 halves y equals 1/2 minus 18. All right, now let's complete the square. Here we go. So if I'm going to expand this out, I know I'm going to get twice whatever value I write here. And I need 2 times this value to equal 19 halves. So I'm going to make it be 19 fourths. Because when I multiply it out, I'll get 19 fourths and another 19 fourths, which will give me 19 halves. Okay, but I have this extra 19 fourths squared being added when I multiply it out. So I'm going to subtract an extra 19 squared over 4 squared. All right, and let's go ahead and move the constant. So here I'll have 19, I'm going to rewrite it this way, 19 fourths squared. I'm just going to keep all this the way it is. Okay, so then on the left-hand side, I've got 9/8x squared and y minus 19 fourths squared. Okay, what have we learned here? So this has a shape that looks like the following. It looks like something times x squared plus y minus something squared equals some constant. So if I look at this, I can see, oh, well, it's not quite a circle because the x term has been dilated, only the x term. So that's either stretched it horizontally or squished it horizontally, depending on the size of the term. And I can see that the y term has been shifted. So the center of what would have been the circle and is now an ellipse has been shifted up. Let's go ahead and type it into Desmos, and we can take a look and sort of see what pieces match with what. Okay, just as a spot check, this looks about right. If I choose a point on the green ellipse, it does look like the distance to the point is about 1/3 the distance to the line. And in particular, if I choose that point right there, okay. I can see that it's 3 boxes from the point to the point at 0, 4, and it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 3 times as many boxes down to the line as it is up to the point. So this is past my spot check. Definitely looks like an ellipse. It looks like it's been horizontally dilated so that it'll contract horizontally. And we should think about kind of how that makes sense. And it looks like it's been shifted up by 19/4. Okay, so you might be, all right, so 9/8, this is a value that's larger than 1. So kind of what happens, another value that's larger than 1 is 2. So you might think like, okay, if I dilate the x-coordinate by 2 or by 3 or by 4 or by 5, the larger the number I'm dilating by, the narrower it gets. And you might think, well, wait, why is that? That feels backwards, Come back in a different video because I think it'll be better to look at how this makes sense using a simpler example than this one. But that's definitely something to notice. If you should always be forming conjectures about what might happen. How do the pieces work? So if you're thinking, well, hey, could we dilate the vertical direction also? So if I dilate the vertical direction by a factor of 2, now both x and y are being dilated by 2, so it sort of looks like a circle, and you can think through why should that be. If I dilate the y direction by even more, now it looks like it's been vertically squished. So it's vertically less tall. Okay, I think that's maybe enough interpreting. Let's go back and look at kind of what was difficult here. So draw the picture, set up the equation. Multiplying out is hopefully not too hard. You just have to remember that the coefficient out here squares and then distributes. And then all the cancellation shouldn't be so hard either. So getting down to this point, hopefully not so bad. The tricky part is the completing the square. Completing the square is a little bit easier if you have a leading coefficient of 1. So you can always divide through by that coefficient. A couple of tricks to keep in mind are whenever you get difficult to deal with numbers, just postpone doing the computation. Like up here, I didn't bother multiplying 9 and 16. I mean, we could have. But just leaving it as 9 times 16, it eventually ended up simplifying further down the line. On the other hand, if you have large numbers like 76 over 8, here it was worth doing a simplification. And the reason why is because we were going to need later on to square it, and keeping the numbers very large was going to make a later simplification more difficult. So this is part of gaining experience with these problems, is learning kind of what's going to be helpful in your bookkeeping. Like, when should you not bother simplifying? When are you going to simplify? And each problem type is pretty similar. So I'd say do 2 or 3 more of these until you start to feel comfortable with those ideas. Heck, I'm just going to do one more. Here, I'm going to record a new video. Do one more.